So, welcome once again, and we are going to have a lesson today. Our lesson today is on trigonometry, and on trigonometry, we are going to focus on questions uh, that have to do with applying Pythagoras theorem, applying the trig ratios, applying the cast diagram, applying all these other tools. So I want you to understand that we have a question on the board, our first question on the board, which is question 6.1. The question, we are just given root 5 sine theta plus 2 is equal to 0, but theta is an element of 90, minimum is 90 and maximum is 270, which means theta is an element which you find not in the first quadrant, but in the second quadrant or third quadrant or the last quadrant. So we are going to have to draw our Cartesian plane. So this is our Cartesian plane. Now, when we draw our Cartesian plane, what are we trying to do? We are trying to solve the reference angle of theta. How do we solve the reference angle of theta? Let us make sine theta to be equals to the fraction. So in this case, divide both sides by sine theta. It means root 5 times sine theta. If it's equal to 2, negative 2. Divide both sides by root 5. Then we isolate sine theta to be equal to root negative 2 over square root of 5. But now, we understand this from the trig ratio point of view, that if we have SOHCAHTOO, 2, then sine is equal to opposite divided by hypotenuse. So this is going to be the opposite side. Hypotenuse is going to be the denominator. Okay. So what we should do next is to understand that our sine theta in this case, it is negative angle. So now our focus is going to be on the cast diagram. This is the word cast. Am I right? The word cast here. Cast and cast. So on our cast diagram, where do we find sine being negative? Now, start by understanding that sine is positive in this quadrant and in this quadrant. But our domain says it all, that 90 degrees, less than 90 is not necessary. So this is not the quadrant and sine is positive here. So definitely it's out of the picture. Then sine is positive in this quadrant. Again, we're not going to put our angle, our reference angle in this quadrant. Why? Because in this quadrant, sine is positive. So we are left with only one quadrant left, because it must not be beyond 270 degrees. So that means sine is negative in this quadrant. So we shall draw it here. Okay, this is about the cast diagram. So now we know that we're supposed to draw in this third quadrant. So let's draw our angle. This is what is going our angle, what is going to look like. So we draw this, a dotted line, we have this, and we have square root of 5. And we are going to have our opposite. And I want you to understand, opposite is always the y-axis. Opposite, it's always the y-axis. So therefore, our opposite, it is going to be negative 2. So we have negative 2 in this way. This is our negative 2. So now this is going to leave us with going to use Pythagoras theorem to determine the adjacent side. Because now we have our angle is this. So let us use Pythagoras theorem to determine the adjacent side. Let us do that. So we are going to use Pythagoras. In this case, x squared plus y squared is equal to r squared. X is adjacent. We don't have x. Our x, we don't have x squared plus y which is negative 2 squared is equals to r, which is root 5 and squared. So we simplify, our x is going to be square root of root of 5 squared, where 5 minus, this is going to give us 4, which is minus 4. So in this case, we have square root of 1, which is equals to 1. Our x is going to be negative 1. We found that our x is negative 1. So we now have our x, our y, our r. So we are done simplifying our triangle. Now our next step to do is to get into the question to see what exactly are we asked it to do. So the first question that we're asked in this case, we are asking the question about tan theta. So tan theta, now we are answering our questions because we have opposite, we have adjacent, we have hypotenuse. Our tan theta, the question is tan theta. Now, tan theta, we are going to apply the soccer tour, which means tan theta is equal to opposite of adjacent. It is opposite side divided by adjacent. Our opposite in this case is negative 2. Our adjacent, it is negative 1. So therefore, if you divide the 2, you're going to get positive 2. Just like that. So this is tan theta, which is equal to positive 2. So the next question, it was about cosine 2 theta. Cosine 2 theta. Let's determine cosine 2 theta. As we can see, our angle is not 2 theta. Our angle is theta. So to determine cosine 2 theta, it means we are supposed to use the double angle for cosine. How do we use the double angle for cosine? We can take any angle. So there are identities of cosine 2 theta. Main identities. So let us take the identity, which is 2 cosine squared theta minus 1. So to our cosine theta we have, our cosine theta is adjacent divided by hypotenuse. So adjacent is negative 1, hypotenuse is root 5 squared minus 1. Now, what you need to do at this stage is to simplify. How do we simplify that? We're going to simplify with 2 brackets minus 1 squared is 1, root 5 squared is just 5 minus 1. So if you multiply by 2, which means we have 2 over 5, subtract 1. Our answer is negative 3 over 5. This is the final answer, which is negative 3 divided by 5. So basically, these were the only 2 questions regarding this question that we are given here with its domain. So let us move on to our next question. So moving on to the next question, our next question has nothing to do with the first question. We are done with the first question. We no longer apply everything that we're using on the first question. The next question is about determining, we have 2 sine, we have 2 cosine squared 15 minus 1 plus 2 sine 140 divided by cosine 310. So this is our question. We are supposed to determine this to 1 trigonometric ratio. How do we determine this to 1 trigonometric ratio? So what are the tools? What are the tools that need to be used? So the first thing to do is to check if we're a fraction. Yes, there's a fraction here on this other side. We must be able to solve fractions. That's the first thing. The second thing to do is to be able to use identities. How do we use identities? We must identify anything that is identical to any of the angles that identities, be it double angles, be it compound angles. So in this case, we have the first part here. As you can see, that there's an identity which says cosine 2 theta, it is equals to 2 cosine squared theta minus 1. So using this identity, we can reduce this to cosine 2 theta. Our theta is 15. So basically this means that 2 times 15, this is going to give us cosine 30. So this part becomes cosine 30. Now, let us deal with this fraction here. Our fraction has sine 140. Now, what we should understand is to target the number, only the number, which is 140. Let us deal with 140. 140 as the number is a number we can rewrite in terms of cast diagram values. It's the same as 180 minus 40. So sine 140 can be written as sine 180 minus 40. Okay? Then 310. 310 using cast diagram values, which is 90, 360, 180. This can be written as 360 minus 50. Okay, so we're going to replace sine 140, sine 140, so which means this is going to be sine 180 minus 40. Now, sine 180 minus 40, in which quadrant do we find 180 minus? It is in the second quadrant. In the second quadrant, we find sine 180 minus theta to be positive. So this can become 2 sine 40. Let us deal with the denominator, cosine 310. So cosine 310 can be written as cosine 360 minus 50. Cosine 300 and minus 50. So now in this case, this is going to come down. Cosine 360 minus 50 is we are going to use quadrant, the last quadrant. So this can become cosine 50. So if this is cosine 50, now dividing the two, that's 2 sine 40 divided by cosine 50. We are also going to encounter a challenge because we cannot eliminate the two. They are different angles. But understanding that cosine 50 can be rewritten. We can rewrite cosine 50 to be cosine 90 minus 40. So cosine 90 minus 40, what is it going to give us? Cosine 90 minus 40 is we are going to use quadrant number 1, where all angles are positive. So this is going to change to become sine 40. If it changes to sine 40, then now we can simplify everything in one fraction. So let us simplify our question. So simplify our question, we are going to have to rewrite our question from here. This part became cosine 30 plus this part became 2 sine 40 divided by this one became sine 40. So it is at this stage where we can eliminate, and we are going to have cosine 30 plus 2. But we are not done because we must also simplify cosine 30. Simplifying cosine 30, we need to be able to apply what are called special angles. So our special angles that we are going to use, this is the special angle where we have 30, we have 60, we have 2, we have 1, and root 3. So cosine 30 is going to be, cosine 30 is adjacent of hypotenuse. So this is going to be adjacent, which is root 3 of hypotenuse, which is 2 plus 2 over 1. So finally, our answer, we can cross multiply and have root 3, 2 times 2 plus 4 divided by 2. This is our final answer to this particular question. But the steps involved, I guess you can see how we deal with this, how we do this separately until we get to our final answer. So let's move on to the next question. So the next question here is a question on we are given sine x over 2 is equal to p. But the question is that you need to express sine 2x minus 1 in terms of p. In terms of p. You need to express sine 2x minus 1 in terms of p. Now, if you get something like this, the first step to understand is that this is your angle x over 2. Let's bracket it so that you don't confuse. There is a difference between sine x over 2 and sine x over 2. These two are different. So let us be able to understand that what we're dealing with is this type, not this type. So from there, our reference angle is p. Let's make it a fraction. This is going to be p over 1. If it becomes p over 1, then we should draw a triangle which is 90 degrees and be able to put a sine of this angle is p over 1. Our p becomes, so the angle is x over 2. So if the angle is x over 2, that means this is the opposite, this is the hypotenuse. So the opposite is p, the hypotenuse is 1. Now we need to find the adjacent using Pythagoras. X squared plus y squared is equal to r squared. Our x, in this case, we don't have this one. Our y is p squared. Our hypotenuse is 1 squared. So let us simplify. Simplifying this, it means x is equal to square root of 1 minus p squared. So we found this adjacent side, x side, which is square root of 1 minus p squared. The next step to do is that we need to understand what are we expressing. We are expressing sine 2x minus 1. Sine 2x minus 1. So sine 2x, what we should do at this step is to understand that if we are to express sine 2x minus 1 in terms of p, sine 2x minus 1, okay, this is sine x, okay, let us fix this. This is sine x minus 1. So sine x minus 1, sine x minus 1 in terms of p. Sine x, let us understand that this is the same as, if I'm to put a hypothetical, there's 1 here. This is sine 1x. Now, this is very important. The reason why I put 1 is that we can rewrite this part, which is sine 2 bracket x over 2 minus 1. This is the same. Sine 1x minus 1 is the same as sine 2x over 2 minus 1, because simplifying this, it means that this will still give you 1x. 1x and say 2 bracket x over 2 is the same thing. So we have a double angle here. So since we have a double angle, now what is the double angle for sine? It's going to be 2 sine x over 2 cosine x over 2 minus 1. What is sine x over 2? We come to our triangle. Sine x over 2, the angle we have, it is opposite of hypotenuse. We have 2 bracket opposite. Our opposite is p over 1. Cosine is adjacent over 1. Our adjacent is square root of 1 minus p squared over 1. Subtract 1 at the end. So what is needed now from this step is to simplify from this. 2p bracket square root 1 minus p squared minus 1. This is finally our answer. If you divide everything by 1, it remains the same. So our final answer is going to be, we leave it in this state. This is the final answer of expressing this in terms of p. So this is basically how we can solve this. So understand, your question should guide you. 1x is the same as multiplying this by 2. You get 1x. So we have a double angle case. This is a double angle case. So a double angle, we should use the identity for double angle, which is this one, until we get to the final answer. So let's move on to the next question. So moving on to the next question, our next question, it is an identity. We have an identity. The identity is 3 sine x plus 2 sine 2x divided by 2 plus 3 cosine x plus 2 cosine 2x. This is the identity. They say it should come down to tan x. It should come down to tan of x. What is the first step from this? This first step is to understand if you are given any fractions. So in this case, yes, we have a fraction. What is our fraction? Our fraction at this point is just the whole numerator and denominator. This is one fraction. So since it's a fraction, we need to identify any compound angle or any double angle. Anything that we have is identity ready. So in this case, we have sine 2x. We also have cosine 2x. So to get tan x, we must understand its sine over cos. On the numerator, everything that has to do with sine, with cosine, must be isolated. So let us start. 3 sine x plus 2 bracket 2 sine x cosine x. The double angle for the identity. Then we divide by 2 plus 3 cosine x plus 2 bracket. This is going to be the double angle for cosine. Let us choose. Cosine has 3 double angles. So let us be very vigilant and choose the double angle, which is going to eliminate any unnecessary information. So the double angle that we're going to use, it is the one for 2 cosine squared x minus 1. We use this double angle. Let us simplify now. The numerator, we can factor out sine x on the numerator. Factoring out sine x, it means we're going to have 3 plus 2 times 2 give you 4 cosine x. So that's our numerator. Our denominator, let us simplify the denominator. 2 plus 3 cosine x plus 4 cosine squared x minus 2. But we can see from this that 2 and 2, they are going to cancel out. When they cancel out, we are left with 3 cosine x plus 4 cosine squared x. So therefore, let us rewrite the numerator. The numerator, it is sine x bracket 3 plus 4 cosine x divided by the denominator. We have cosine x, cosine squared x, factor out cosine x, open bracket, 3 plus 4 cosine x. So we can now see that what we have in our brackets are similar or like terms. So therefore, we can cancel out. After cancelling them out, we are left with sine x divided by cosine x. And we know that sine x over cosine x has an identity. Its identity is tan x. This is the identity of sine x over cos x. We have proved that this can reduce to tan x. After proving this one, so this is basically how we should prove it. Let's move on to the last question of this part. The last question that we have, a question whereby we are supposed to show that sine x over sine x plus cosine x divided by sine x minus cosine x can be written as p plus t over p minus t. In this case, tan x is given as p So we have a condition. We have a condition that if, this is a condition, tan x, if tan x is equal to P over T. Now, if tan x is equal to P over T, what it means is that we need to use a triangle. Let's draw a triangle. The triangle will look like this, where we have this, and our angle in this case is x. This is opposite over adjacent. Our opposite is P. Our adjacent is T. So, since we have this, what is short is to find what is called the hypotenuse. How do we find the hypotenuse? To find the hypotenuse, which means we should use Pythagoras theorem. Using Pythagoras theorem, we have x squared plus y squared is equal to r squared. X is t squared. Y is p squared. R is r squared. Don't know, I simplify r squared. R is square root of t squared plus p squared. That's our r. So we now have a hypotenuse which is square root of t squared plus r plus p squared. So now we can now simplify this by substituting every reference angle for sine, for cos, and on this equation. Let us do that. So sine x is opposite